Dear students, நாம் இப்போ பார்க்க போகிறது இந்த வீடியோவில் 12th standard physics first chapter electrostatics. This is Tamil State Board syllabus. இந்த வீடியோவில் நாம் இப்போ பார்க்க போகிறது electric field and electric field lines. இது வரைக்கும் இந்த சேனல் சப்ஸ்கிரைப் பண்ணாதவங்க சப்ஸ்கிரைப் பண்ணிக்கோங்க. ஃபர்ஸ்ட் டாபிக் electric field. Electric fieldனா என்னன்றதை பார்க்கறதுக்கு முன்னாடி, if you consider a point charge which is kept at a point in space, and if you are bringing another point charge and keeping it at some distance from the first point charge, then it experiences an attractive force or repulsive force, and this is called action at a distance. But how can you know that the second charge is experiencing a force when you are bringing it near the first charge? For this, Michael Faraday introduced the concept of field, that is called as electric field. So according to Faraday, every charge in the universe creates an electric field in the surrounding space, and if another charge is brought into its field, it will interact with the electric field at that point and will experience a force. So I repeat, according to Faraday, every charge in the universe creates an electric field in the surrounding space. And if another charge is brought into its field, it will interact with the electric field at that point and will experience a force. So if you are considering a point charge Q, which is located at a point in space, then if you are bringing another point charge Q0, that is called as test charge, when it is placed at some point P, which is at a distance r from the charge Q, then the electrostatic force experienced by the charge Q0 due to Q is given by Coulomb's law, as you all know. That is given by the expression F is equal to K times Q0 by R square R unit vector, and that is equal to 1 by 4 pi epsilon naught Q0 by R square R unit vector. This K has a value of 1 by 4 pi epsilon naught. So here you see that the force is given by the electrostatic force is given by Coulomb's law, and if you want to calculate the electric field, what you have to do is the electric field at the point P, you have to consider that this the point P at a distance r from the point charge, and what is the force experienced by that unit charge, that is given by E equal to F by Q0. So here F is equal to KQ by R square R unit vector, and that is equal to 1 by 4 pi epsilon naught Q by R square R unit vector. So this is the electric field which is created by the charge Q when it is kept in a point in space. So here R unit vector is the unit vector pointing from Q to the point of interest P. Now the electric field is a vector quantity, and therefore it will have both the direction and magnitude, and its SI unit is given by Newton per Coulomb. It is also written as NC power minus 1. Now we are going to see the important aspects of electric field. The first one is, if the charge Q1 or Q is positive and the electric field points away from the source charge, and if Q is negative, the electric field will point towards the source charge. So that is given in this diagram. You see that the positive charge, if it is placed here, then the electric field will be pointing outward, that is pointing away from the source charge, for a positive source charge. Similarly, so here it is this red arrow mark shows the electric field, and this blue arrow mark shows the R unit vector. This is a positive source charge. Similarly, if we consider a negative source charge here, then R unit vector is pointing like this, the blue arrow mark, and the electric field will be pointing radially inwards, that is denoted by this red arrow mark. So here these two illustrations explains the electric field of positive and negative charges. Next, the electric field at a point P is E. Then the force experienced by the test charge Q0 placed at the point P is given by the expression F is equal to Q0 times E. So this is Coulomb's law in terms of electric field, and that is given by this illustration here. So the electric field is given by F equal to Q0 times E. If the test charge is Q0, which is also positive charge, and when it is brought near this positive charge plus Q, then the force acting on it is given by F equal to Q0 times E, where this E is directed away from this point positive charge Q. Similarly, if you are bringing a positive test charge Q0 towards a negative charge, then the electric field will be directed towards the charge minus Q, and the force is given by F is equal to Q0 times E. And here the next point is given by the electric field is independent of the test charge Q0 and depends only on the source charge Q. Over here the equation F is equal to Q0 times E. By seeing that expression, we can conclude that the electric field will be independent of the test charge and it depends only on the source charge. Next important aspect is given by this point, that is if the electric field is a vector quantity, considered as a vector quantity, then at every point in space this field has unique direction and magnitude. So we can conclude that as the distance increases, the electric field decreases in magnitude. So that is given by this point. And then, so that is explained in this diagram. You see the points P, Q, and R. The electric field at the point P due to this charge Q, the positive charge Q, is given by this EP. And the point R, at the point R, the electric field is given by ER. And at the point Q, the electric field is EQ. Note down that these arrow marks, they are lengthier than this electric field at the point Q. You see EP is greater and ER is also greater than EQ. Similarly, for a negative charge, you see that the point P, Q, R, there are three different points P, Q, and R. The electric field will be directed towards the charge EP, and ER is also directed towards the charge. And you note down that these two arrow marks are having greater length than this EQ. Now the next point is that the test charge Q is taken sufficiently small, and so that bringing that this charge will not move the source charge. Therefore the test charge is made sufficiently small such that it will not modify the electric field of the source charge. The expression 1.4 will be valid only for point charges, but for continuous and finite size charge distributions, we have to apply some integration techniques that we will see later. Now that is only an approximation for a finite size charge. And the next important point is that there are two kinds of electric field: uniform, that is constant electric field, and non-uniform electric field. What is meant by uniform electric field? That is, a uniform electric field will have the same direction and constant magnitude at all points in space. But the non-uniform electric field will have different directions or different magnitudes, or both at different points in space. The electric field created by a point charge is basically a non-uniform electric field. This non-uniformity arises both in direction and magnitude, with the direction being radially outwards or inward and the magnitude changes as distance increases. So that is shown in this figure. You see this uniform electric field and this non-uniform electric field. This non-uniform electric field can also be represented by these diagrams. Non-uniform electric field here. So this is what we have to learn from this topic. We will see the rest of the things in our next video. மறக்காம இந்த சேனல் சப்ஸ்கிரைப் பண்ணிக்கோங்க. Thank you.